We'll put an H
So
there.
your HO is your expected.
HO is expected.
HA is outcome.
HA is what it actually is. The problem is there.
Simplest thing. She told you what it is. Just say yes.
The advantage. If your probability is greater than 0.083, you say then there's an advantage.
Yeah, what's that red square?
Or what we think might happen.
Orange.
But like, where's exactly? All
So
right.
you're just switching Z-score, what we got originally around. Like you're switching it so it's above instead of below.
Exactly.
Why are we switching it so it's above instead of below?
Because right now we're saying that about 90%, 90.8%
Yeah.
are in this, about up to this 1.33 mark. We want to see the people above it. If there's an advantage.
What is signifying why you would want to look above that 1.33? What is the question?
Advantage to going last. Would they have a better outcome?
So what would it say if you wanted to know what was below 1.33?
Maybe like golfing scores, something that is measured lower. Trying to be the quickest on the field when you're trying to run. So when you're trying to get a lower score
You're
versus a higher
trying to
score.
find whatever the best is.
Exactly.
But
And
if
for
the
this,
best is at the end, then you go to the end. If the best is lower, then
you got it. Depends on the problem. Okay? So when we figure this out, this is our p-value right over here. What does 1 take away 0.9082?
0918.
This is that p-value up here. So keep in mind, when we were doing the card activity, okay, we started getting around 5%, and people were thinking what?
This is missed.
It was not working, right? When we got to 2.5%, Brandon said this whole thing was 2.5. It was not working. Some people said even at 3 that they were thinking it was completely rigged, or there was something wrong once you started hitting 3. What we're looking for is this significance level. This is about 9%. So look at this up here. When the p-value is small, it's very rare to happen. When it's large, we think it could actually happen. There's a sentence that we have to do to put all this together. Okay, and then we'll look into it a little bit more on the next page for the next problem as well. Before we use these, you always have to make sure those 3 things are always checked. Is it random? Is it, what's the other ones? Normal? What's the other one? Nope. Normal would be the one that fits in there.
Random.
Independent. So you're looking to see, yeah, it's the same conditions as before. We can only do this if we have a random sample, which we did. If it was normal, or if you have that NP is greater than 10 and N1 minus P is greater than 10. And if that 10% rule, then we don't really care about it being independent. So we still have to make sure those 3 things fit. But when we get a value like this of 9%, we say it's not that significant. So the way we word it is, and it's a whole sentence, and then, Brandon, this is going to be part of like when you have to do the problems, it's going to be, if you don't word it in that way, then that's why it's not going to be accepted, or like it has to be worded in a certain way. So since the p-value is greater, and when we aren't given an alpha, we're going to assume it's that 0.5 or 0.05. We're going to assume it's about 5%. That's that typical roundabout area. So since the p-value is greater than alpha,
And that's the PO.
nope, that's this guy, the significant level over here.
Oh.
Those are set levels, those never change.
Those are pretty set levels. We're sticking with this one whenever in doubt.
Because it's just so.
That's pretty much the breaking
So wait.
point in natural.
If it's bigger than this,
Progression.
is it considered large then?
If it's bigger than that, it's considered large.
Okay.
Because a lot of people will say, well, what's too small? What's too big? What number am I looking for? That's that breaking point right there.
Symptom before me,
Alpha.
sideways taken out.
Alpha. Since the peak value is greater than alpha, I fail to reject the null hypothesis. And there's another sentence after, but I want to talk about it for a second. When you look at these, pretend like this is your null hypothesis is your innocence. And your alternative hypothesis, if you're not innocent, you're guilty. So, a lot of times when you go on a jury or something like that, you might not be necessarily proving, if it's guilty, they're guilty, right? Once you prove them guilty, they're guilty. If you don't prove them guilty, are they necessarily innocent? No, but you failed to prove them guilty. So this is the same type of thing. You are either you're not going to accept anything. You're either going to reject this null hypothesis. If you get a number that's really, really, really small, because you're going to say there's no way that possibly could have happened, or you're going to fail to reject. Fail to reject seems kind of like the word accept. Like if I fail to reject something, you might think of accepting something, but that's not really the way it
You're not
works.
saying no, but
Correct.
you're not agreeing with it either.
Exactly. So we have to use that word, fail to reject, because we don't want to say the person's innocent when they might have really killed the man. We just say we can't convict them at that time, or there's not significant evidence. And we say the same thing in this.
There really should be a whole other language for math.
I know. There is not sufficient evidence to suggest that there is and for this problem, an advantage for the way you perform, like performing last. You always have to put it in context and bring the question in. It's a ton of information, and I want to make sure that we go over it. That's why I got another problem on the back part too, so that we can set it all up again. But if you look at the meat and potatoes of the problem, you're doing a z-score, right? And then you're finding the probability of it. It's not really much different than what you've been doing this whole entire time. So the wording is strange, and the way that adding this new p-value and this new alpha symbol is a little bit of a new thing. But as far as doing the z-score, you're a pro at doing the z-score. I know because I grade your tests. And those are not what we have problems with. So the basic meat and potatoes is actually doing a z-score and finding it out from the table. And then this is probability or population proportions. In the next section, we're going to be doing population means, which is going to be doing t's. So we're going to bring that t back again. It's the same exact thing that we were doing last chapter. Let's hear it.
Well, what does it mean to fail to be neglecting the null hypothesis again?
Okay, if you think of this as being your innocence, you always want to prove something, you always want to think that the person is innocent, right? Unless proven guilty, right? So if we find that there is a very small p-value, that is that alpha here, your significance level. Same thing when we were doing the card activity. And we said by the time we got about 5%, we were thinking this can't happen. But when you see a very, very small, we say this is too rare to actually occur. So we reject that this person could be.
0.15?
Yes. So that's why this is actually considered a large number. So this actually could happen. This null hypothesis could happen. They could actually have a probability of going last could be 1/12 instead of bigger than 1/12, which would mean they'd have an advantage. Getting there? Let's try another one from scratch. P-value represents the chance that this could happen. But by chance that this could happen. Like I know of
The chance that it's not fake. That's not real.
the chance that even though it's supposed to be 1/12, if they got it a little off, how far off is it? Is it so far off that it can't possibly occur? Or
I'm finally understanding this.
think you're getting there?
Practical
there.
intelligence.
Okay, so
So that
let's
has no
I'm
relation
guessing
to
I'd be like, okay, well, they're close enough.
it is its own entity now.
Okay.
This check
It is connected to the 1/12 because we use the 1/12 here, we use the 1/12 here. It's connected to the 1/12, but it's saying mainly because of this statistic, 59/600. That is what's driving this to see whether that could actually occur or not by chance. Yes, sir, Tom.
So the p-value is the z-squared minus 1. We're always going to subtract it.
No, we're not always going to subtract it from 1.
How do we know it's
It depends on the wording of the problem. For this one, we're looking for an advantage of going last, so we're looking for numbers bigger. If we're looking at somebody's golf score to improve, we'd actually be looking for numbers lower. So it depends, or their running time to improve, we'd be looking for lower numbers. So it does depend. PA. This is what we are trying to say. If this doesn't happen, then this. Let's test and see if this happens. It's like,
So what is like PA though?
we're testing it. We're trying to see what the p-value, this is our p-value that we're trying to test. So we could end up here, we could end up here, or we could end up here. It turns out we ended up more in, we're going to we're going to not reject this guy right here. It's either one of these, what we're trying to say. It's they're either innocent or they're guilty. It's one or the other. But they're standing for the same number. See what I'm meaning? Alright, let's try another one. Did he?
Yeah.
Alright, flip this speaker over and let's try one more. So let's go through a few things. This is another one. I think this is the drug, a test study. Oh, no. This is the fraud. Oh, I like this one.